Okay, in section 4.3 we're going to continue our discussion on logarithms, and we're going to learn a bunch of rules. So let's just kind of learn the rules as we go. I'll break them down for us. So it says use properties of logarithms to expand each logarithm. So we're going to take one log and make it into several. Okay, so the first one we're going to need is this rule. That is, if you have the log base b of m divided by, let me write this a little differently, if you have the log base b of m divided by n, we can break that into two logs, log base b of m minus log base b of n. So we can take log 11 over y and make it into log 11 of 11, the top thing, minus log base 11 of the bottom thing, y. So notice they each get the exact same thing. So log 11, minus in between, top minus bottom. Okay, then the only other thing we need is this one. If you have the log of base b of b, that's equal to 1. So if you notice, this 11 and 11 match, so if you get these two to match, the whole thing will just become 1. So the final answer for this one would be 1 minus log base 11 of y. And that will be the final answer. Okay, for the next problem, we're going to use a very similar property. Let's start boxing some of these so we can keep them. These are on your equation sheet. That's on Canvas on the in the tools section, or in the modules section, excuse me. So you have all these equations, but I'm just going to write them so we have them handy. Okay, now natural log, ln, works the same way as log. So I could write ln m over n is equal to that, but it's the same property. So I'm not going to write a separate case for each type of logarithm. So we can still write this as ln of the top stuff minus ln of the bottom, which is 4. So break that division. When we see division, we're going to think subtraction. Now we're going to remember, hopefully, that ln is base e. So if you have ln e to the x, those also collapse, and the answer is just x. The answer is just the power. So this ln e are going to cancel, and the whole thing is going to simplify to just 5. So this is going to be 5 minus natural log of 4. And that answer there. Okay, for 27, we have to recall a power rule. So if I have the pth root of x, that's really equal to x raised to the 1 over p. Okay? So we're going to write this as the natural log of x raised to the 1 over 9. Okay, then we have our next rule, which says this. If you have the natural log, let's write it as log. If you have log or ln base b of x raised to a power p, we can bring that power out in front. So this is where I had mentioned logarithms kind of decrease the complexity. So powers become multiplication. Division becomes subtraction. So subtraction is easier to do than division. And then we'll see what multiplication comes in a minute. So powers become multiplication. So this p is going to be multiplied by log base b of x. And you pick up that rule, that formula. So we are going to bring this p down, this power down, and we will write this as 1/9 times the natural log of x. And that will be the answer for this one. So a lot of these problems, they just take a few steps, but you have to know all the different rules that apply to logarithms, which we have provided in the equation sheet. Okay, 28. We have log base 5, and we have something divided by something else. So the first thing we're going to do is split this into log base 5, or whatever's on top, minus log base 5, whatever's on the bottom. And we're going to introduce or remind us, we've seen this rule in the previous section, that if you have the log base b of b to the x, that's just equal to x. So the one below it, log base b of b equal to 1, that's actually just a subcase of this one I just wrote, where the power is 1. So when we saw log 11, 11 had the power of 1, and so the 11's canceled, and it just became 1. Well, that's a subcase of log base b of b to any power x. We'll just reduce to x, the power. And we're going to use that because we're going to say, okay, 25 can be written as 5 squared. So we write 25 as 5 squared, and then we're going to be able to use that log base b of b rule. Then we're also going to write this one as not the square root of x plus 5, we're going to write it as x plus 5 to the 1/2 power. And then we're going to see, based on that rule I wrote, these will cancel. The result will just be 2. And we're going to bring this 1/2 down. So we're going to have 2 minus 1/2 log, oh, I forgot base 5, let me write that, base 5 of x plus 5. And we see we don't have any division anymore, we don't have any square roots anymore. It's a much simpler formula, much simpler expression to evaluate. Alright, for 29, we have what looks like a pretty complicated expression, but we're going to just deal with it one step at a time. So the first thing we're going to do is rewrite this as log base 8 of parentheses s to the 4th times t divided by 64. We're going to write that to the 1/5 power. So we're going to use this square root property that says we can write a square root, a root as a fractional power. So it'll be 1/5 of the power. Then we're going to bring that power out in front. So we're going to have 1/5 log base 8 of s to the 4th times t all over 64. And now we can use our division rule. Our division rule says we can subtract the top and the bottom. So this is going to equal 1/5 log 8 s to the 4th times t minus 1/5 log base 8 of 64. So notice the 1/5 log base 8 is applied to both. So let's underline that. Notice 1/5 log 8, 1/5 log 8 are the exact same. So we apply that to both the top term and the bottom term. Now we're also going to notice that these are being multiplied. So we need a rule to handle that. So if you have a log of two things being multiplied, log base b of m times n, that's the same as the log base b of m plus the log base b of n. So it's very similar to the division rule. Division, we use subtraction. Multiplication, we use addition. We're going to add those two things being multiplied. Okay, so this is going to equal 1/5 log 8 of s to the 4th. So I'm breaking these two up now. Plus 1/5 log base 8 of t. So notice how that one log became 2 with a addition plus sign in between them. Minus 1/5 log base 8, and I'm going to change this ever so slightly. If it's base 8, try to write 64 as a base 8 number. Well, we know 64 is 8 squared. Okay, so now we can do one last step. This 4 will come down and multiply into the 1/5. This log 8 will cancel, and this whole thing will just be 2, which will come down into the 1. And so the final answer will look like this. 4/5 log base 8 of s plus 1/5 log base 8 of t minus 2 over 5. Try to write that as carefully as I can so you don't confuse my s's and 5, and you can see how everything is going to collapse and or expand. So we took a fifth root, very difficult to compute. We took a s to the fourth, something to the fourth power, very time consuming to do, and we turned it into an addition of two terms and a subtraction of a fraction. So pretty, not too bad to analyze that now that we've got it in a simpler form. Okay, for 30, it's the same idea. We're going to take one log and we're going to expand it into a bunch of them, and we're going to simplify as we go. So one thing you notice is you have log. They have not given us a base. And let's just remind ourselves, if they have log with no base written, it is understood to be base 10. And this is also the base that your calculator will work in. So your calculator can do base 10 logarithms if you type it in, log button. So we're going to take, the first thing we're going to do is we're going to take everything on top, call that m, take everything on bottom, call that n, and we're going to use this division property. So we're going to write 1 log as 2. We're going to have everything on top, 10 times x squared times the cubed root of 4 minus x minus log base 10 of everything on the bottom, 7 times x plus 5 squared. And now we're going to write, let me put parentheses around all this. So these are arguments of the log. Now I'm going to mark where we have multiplication. This 10 is multiplying that x squared. This x squared is multiplying that cube root. This 7 is multiplying that x plus 5 squared. And everywhere I have those dots, they're going to turn into addition. So we're going to use this rule. Things being multiplied will turn into logs that are being added. So this is going to break into log 10, and now it's going to be plus. So this multiplication turns into a plus. And then it's log x squared. Then this one's going to turn into a plus log of the cube root of 4 minus x. Then we have this minus sign. Now I have to be a little careful here. This is minus this whole thing. So I'm going to use big parentheses there. And I have log 7 plus log x plus 5 squared. So this one also turned into this plus sign here. Okay, so we've taken the division, broke it into subtraction. We took all the multiplications and turned them into additions. And now what else can we do? Recall that this is log base 10. So if we have log b of b, log 10 of 10, that should reduce to 1. So this is going to be 1. We're also going to move this 2 out in front. So we're going to have plus 2 log x. We're also going to write this one, instead of the third root of that, it's going to be log of 4 minus x to the 1/3 power. So we're going to write the third root as a power 1/3. Now we're going to distribute this minus sign. So this minus will go into here, and it will also go and override that plus. And we're going to simultaneously bring this 2 down. So a couple steps there. We're going to have minus log 7, and minus 2 comes down in front, 2 log x plus 5. Okay, now I believe the last step we have is to just bring this 1/3 down, and we can write it. Our final answer should be 1 plus 2 log x plus 1/3 log 4 minus x minus log 7 minus 2 log x plus 5. And that would be the final answer. So a lot there, I realize, but if you go through and you use your rules that we have in green here on the right, or in your equation sheet that you can get from our online class under Canvas, you should be able to get to this step. And notice, what are we looking for? We don't have any powers anymore. We don't have any multiplication anymore. We don't have any division anymore. So those three difficult things to do, certainly more difficult than adding and subtracting, have been completely reduced to just a couple terms being added or subtracted, and that's the goal. Okay, in the next half, we're going to go the opposite way. So in those first round of problems, we took one log and expanded it out, made it into technically a simpler problem. You have more logs, but as long as you have a calculator that can handle those, we're just adding and subtracting logs. Now in this one, we're going to take multiple logs and cram them back into one. So we're going to do the reverse of all these equations. Okay, so we're going to use the reverse of log m plus log n equals log. 2 logs added is the same as 1 log, where you multiply those two things. So log 20 plus log 5 would just be log of 20 times 5, but that is log of 100. And recall, log without a base is base 10, so we can write that as log base 10 of 10 squared. So 100 is 10 squared, and then we can see that because the 10 and the 10 match, they'll cancel, and the answer is just the power. So this one reduces quite nicely to just the number 2. Okay, in problem 32, it's pretty similar, 2 logs being added, but we have to reverse this power rule. So the power rule said I can bring powers out front. To reverse it, we're going to take numbers out front and make them powers. So this will become the natural log of x to the 1/4 power plus the natural log of y. Okay, we're also going to use the reverse of our fraction power rule. So the fraction power rule says I can write the nth root of something as x to the 1 over that number. So therefore, I can take a fractional power like 1/4 and write it as the 4th root of x. And now we'll use our log property. So our log property says 2 things being added can be 1 thing that is multiplied, and typically we'll write y times the 4th root of x in that order, just so we can see that it's multiplied and that the y is not a part of the square of the radical symbol. Okay, so that would be it for 32. Okay, in 33, very similar. We're going to start by reversing these numbers out in front, so the 6 and the 2 will both become powers. And then we're going to get natural log of x to the 6th minus natural log of y squared. And now we're going to do the opposite of the division rule. So division becomes one log with things being divided becomes those 2 things subtracted. So 2 things subtracted will become division. And the way we do the order is the first thing goes on top, the thing being subtracted goes on the bottom. So this would be the natural log of x to the 6th over y squared. 2 logs become 1. Okay, very similar, 34. First, we're going to start in the parentheses and make this 1/2. 2 logs become 1. Log base 9 of s times t. So of st. So log s plus the log t becomes log s times t. Then we're going to pull this number up as a power. So we're going to get, this is log base 9 of st raised to the 1/2 power. But then we're going to remember that a 1/2 power is really a square root. So this is log base 9 of the square root of s times t. Okay, 35. Same idea, we're going in reverse. So the first thing we're going to write is this is 1/2 log base 2 of x times y. And then it's going to be minus, let's bring that 6 to the top, and we'll call it log base 2 of x plus 3 to the 6th power. And now in the next step, we are going to bring the 1/2 up, and we'll call this log base 2 of xy to the 1/2 power minus log base 2 x plus 3 to the 6th. And then we can recall again, 1/2 power is really the square root. So it's square root xy minus log 2 x plus 3 to the 6th. Now we're going to use our division rule. So we can make two logs into a division. First thing on top, so it's going to be log base 2 of the square root of x times y divided by x plus 3 to the 6th. So we have the first term goes on top, the thing being subtracted goes on the bottom. And that would be simplified, a couple logs it into 1 for problem 35. Okay, for the last problem in this section, I'm going to add another property to our list. And this is one we've seen before, but let's review it. And that's called the difference of perfect squares. So if you have two things that are perfect squares being subtracted, you can factor that to a plus b, a minus b. Again, we've seen that all the way back in chapter 2, and we've used it in chapter 2 and 3, and now again in 4, so hopefully it's not too unfamiliar to us. And basically that's going to allow us to take something like x squared minus 25 and factor it into x plus 5, x minus 5. In fact, that's the first thing we're going to do on this problem. So we're going to have log x, base 10, notice, since there's no number given, it's base 10. Then I'm going to have plus log of not x squared minus 25. Let's break it into those two chunks. The log of x plus 5 and x minus 5. Then minus log 9 and minus log x plus 5. Okay, now here we're trying to collapse this into one log, but I'm actually going to do the opposite first to get a shortcut. And that is to notice that this is being multiplied. So I can break that into two logs being added. So let's break those up. So we have log x plus log x plus 5 plus, from this one right here, log x minus 5 minus log 9 minus log x plus 5. And what we're going to hopefully notice is we have a plus log x plus 5 and we have a minus log x plus 5. They have the same argument, the exact same log, same base. One's plus, one's minus. They're going to cancel each other. So this whole term will cancel with this whole term. And we're going to get log x plus log x minus 5 minus log 9. So we can eliminate two terms if we do that, which is going to make it a lot easier. Okay, now we're going to combine two logs being added into one log being multiplied. So it's going to be log x times x minus 5 minus log 9. And now we're going to take two logs being subtracted and make them one log of division. So the final answer is going to be log x, x minus 5 on top, and the 9 on the bottom. And that would be the simplified version of 36. All those logs, minuses and pluses, and we combine into one log that includes a multiplication and a division. That would conclude 36 and conclude section 4.3.